Ever wondered about the different types of foundations used in civil engineering? Well, you've come to the right place. Foundations are, quite literally, the basis of any construction project. They're the element that transfers the load of the structure to the ground. Without a solid foundation, even the most magnificent buildings would crumble. Now, there are two main categories of foundations we'll be focusing on: deep and shallow. The type of foundation chosen for a project depends heavily on the soil conditions and the load the structure needs to support. Shallow foundations, as the name suggests, are set less than 3 feet into the ground, while deep foundations can extend dozens if not hundreds of feet below the surface to reach more stable soil or rock layers. So, the next time you pass by a construction site, take a moment to marvel at the complexity of these foundational elements. Whether a foundation is deep or shallow depends on the soil conditions and the load it needs to support. Deep foundations and shallow foundations each have their unique characteristics and applications. Let's start with deep foundations. These are generally used when dealing with structures that require strong support due to heavy loads. They also become necessary when the soil at the surface is weak or unable to adequately support the structure. Skyscrapers and bridges are typical examples of structures that utilize deep foundations to ensure stability and safety. On the other hand, we have shallow foundations. These are commonly used in buildings with lighter loads and strong soil conditions. They are typically employed for residential or small commercial buildings. The primary advantage of shallow foundations lies in their cost-effectiveness and ease of construction. However, it's worth mentioning that the choice of foundation isn't a matter of preference. It's a strategic decision made after careful analysis of the soil conditions and the structure's load. The choice between a deep or shallow foundation requires careful analysis of the soil conditions and the structure's load. Foundations aren't the only crucial elements in civil engineering. Columns, beams, and slabs also play integral roles. Columns are vertical structures that transfer the load from the top down to the foundation, while beams are horizontal ones that distribute the load to columns. Slabs, on the other hand, are flat platforms on which we walk or place objects, transferring loads to the beams. Together, they form a harmonious system. Columns, beams, and slabs act as the skeleton of a structure, supporting and distributing its weight. Columns and beams come in different shapes and sizes, each with their unique benefits. Let's start with columns. Square columns, often used in building construction, are popular due to their ease of construction and uniform distribution of load. Rectangular columns, on the other hand, are used when the load distribution is uneven, and they offer more resistance to bending. Circular columns are a common choice for aesthetic considerations, and they also provide more resistance to buckling. Moving on to beams, there are 4 main types. Simply supported beams, the most common type, are supported at both ends and bear a load in the middle. Cantilever beams extend beyond their support and carry the load at the free end. Fixed beams are rigidly fixed at both ends, providing high resistance to deflection. Finally, overhanging beams extend beyond their supports, with a load applied anywhere along their length. The choice of column and beam type depends on the structure's design, load, and functional requirements. Now that we've covered foundations, columns, and beams, let's move on to slabs and concrete. Slabs, much like the foundation, are a key element in construction, providing a flat surface for floors or ceilings. There are 2 main types: one-way and two-way slabs. One-way slabs are simply supported on 2 opposite sides, allowing loads to be carried along a single direction. They are predominantly used in long hauls, bridges, and buildings where one dimension is considerably larger than the other. Two-way slabs, on the other hand, are supported on all 4 sides. This design allows loads to be carried along both directions, making it ideal for larger areas like commercial buildings and residential complexes. Now, while slabs provide the structure, concrete fills them in, and the type of concrete used can significantly influence a structure's properties. Plain concrete, though strong in compression, is weak in tension, hence often used in buildings where tensile stress is low. Reinforced concrete, fortified with steel bars or mesh, handles both compression and tension well, making it a popular choice for a wide range of structures. And then, we have pre-stressed concrete, which is pre-compressed to tackle potential tensile stress, commonly used in heavy load structures like bridges or flyovers. From the foundation to the slabs, every choice in construction materials and design plays a crucial role in a structure's stability and longevity. So the next time you see a building, remember the intricate engineering that went into its creation.